Our video on how to find the area of regular polygons. The formula is pretty simple, right? Area is equal to 1/2 times the apothem times the perimeter. This word we'll define here in a second, but first it's probably important to understand what the word regular means. Right? When we say regular in everyday language, it doesn't mean a whole lot, but in geometry and mathematics it means something very, very specific and very important. And when we say regular polygon, we're talking about a polygon that has all sides the same and all angles the same. So we've seen these before, right? We've worked with regular triangles in the past, right? Regular triangles are equilateral and equiangular. So these are triangles that have 60-degree interior angles and all the sides are the same. Regular quadrilaterals are pretty simple as well. Regular quadrilaterals, another name for that, is of course a square. So these are 90-degree interior angles and all the sides are the same. That goes on and on forever. A pentagon will be next. You'll see a hexagon, heptagon, an 8 would be an octagon, a nonagon, a decagon, and so on and so forth. Right? This word regular means that all the sides are the same, all the angles are the same. So there's a nice little formula to find the interior angles, and there's also a formula that we're going to use a lot in this video to find the measure of the central angles. This angle right in here is a central angle. We'll call that angle theta. To find the measure of that, all you really do is take 360 degrees, which is kind of like the whole circle around there, divided by however many sides there are, because the number of central angles will equal the number of sides. So to find the measure of the central angle of a square, all you do is take 360 over 4, which is 90. To find the measure of the central angle of a regular triangle, it's 360 over 3, which is 120. And it goes on like that forever. The formula to find the interior angles of a polygon is n minus 2, n being the number of sides, times 180. Right? So this would be 3 minus 2 in a triangle case. 3 minus 2 is 1 times 180 is 180 degrees. That's the sum of the interior angles. Over here we know this is 360 because it's 4 minus 2 is 2 times 180 is 360. Right, but this one right here is kind of more important for this video. In any event, let's define this word apothem and then get into a couple examples here. So the word apothem is basically defined as the segment from the center of the regular polygon to the midpoint of its side. The segment from the center of the regular polygon to the midpoint of its side. And we're going to use that right up in this formula, right? It's 1/2 times that times the perimeter of the polygon. So let's do some examples. Number 1. Directions here are pretty simple. Find the area of this. This is a regular quadrilateral, otherwise known as a square. And what's given to us is not the apothem. This is kind of like the diagonal from the center to a corner, to a vertex. That's not the apothem. The apothem would go this way, and it's always at a right angle. Alright, so what we're trying to do here is not only find the apothem, so the area is 1/2 times the apothem times the perimeter. Notice it's lowercase a for apothem, uppercase for area. So we're trying to find lowercase a, which would be right here, and perimeter would be basically 4 times this side length. Alright, so what I like to do is separate my diagram and make it a little bit easier for myself. So I've got 8 radical 2, I've got a right angle right there, and I need to know this angle right in here. That angle right in there is pretty important. And to calculate that, all I'm really going to think about is the measure of a central angle. So if I were to, let's erase this for a second. So if we were to just try to think about what this central angle is right in here. This is a square. So as I said, it's going to be 360 divided by 4. So that is a right angle, which is kind of intuitive. It looks like it is. But our job right now is to find the apothem. So we're going to cut that in half. So over here, it's not 90, it's half of 90. So it's a 45. That would make this 45 as well. Alright, so the apothem then is 8 radical 2 is the hypotenuse, so that's 8, and so is this. If that number weren't so nice, sometimes it's not so nice, you'd have to do maybe some sine or cosine. All right, so this is 8 right in here, and this half the side is 8. So the whole side is 16 then. The whole thing is 16. Let me do that again. 16 goes from here to here. So all the way around it's 16 as well. 16 all the way around. So here we go. We're ready to find our area. We've got 1/2 times the apothem, which is 8, times the perimeter, which is, let's see, 16 times 4. All right, so you go to your calculators if you need to, right? We go and, let's see, we're in degree mode, doesn't matter for this. 1/2 times 8 is 4 times 16 times 4. So this area is 256. You know, square units, whatever it is. 256 square units. Number 2. All right, so we have a regular hexagon, and the sides of it are 7 inches, and we need to find the area. Well, a hexagon has 6 sides, we know that. So let's actually draw one. Right, we have a hexagon drawn right here. Move it up a little bit. And the sides of this hexagon are all 7. So 7 all the way around, right? And so that makes our perimeter really easy. The perimeter in this problem is simply 7 times 6, or 42. So 1/2 times A times 42. So if you wanted to, you can take 1/2 times 42 and multiply those right now. So really, whatever our apothem is, just multiply it by 21 to get our final area. To find that apothem, we want to put a centered dot here, and let's start by thinking just like we did in the previous example. If we go from vertex to vertex, that creates a nice little triangle, and we want to think about what that angle, that central angle, is. Well, again, the rule is it's always 360. It's 360 because this whole thing in here is basically like a circle, right? And that's 360 degrees. So 360 divided by the number of angles that there are. In this case, there are 6. So the central angle, this is true of every regular hexagon, the central angle is let's see, 360 over 6 is 60 degrees. All right, so let's cut that in half, because what we really want to do is look at just like half of this thing. All right, we just want to cut that in half. So what I'm going to do is just kind of not take 60, but I'm going to take 30 degrees. There's the bell, sorry about that. So we have 30 degrees, and over here we have 7, but we know that it's half of 7. This is half of 7, so this must be 3.5. And then to find the apothem, it's pretty simple. We created ourselves a nice little special right triangle. So if you need to, you can extract that out, right? We've got 3.5, we've got 30 degrees, and we're looking for the apothem. So you can use your special right triangle rules, or let's for this case assume we don't know those. So we'd say, all right, tangent of 30 is equal to opposite over adjacent. So then you go to your calculator and you'd say, okay, let's do 3.5 divided by tangent of 30, 6.062. And that is little a. That's your apothem right there. Again, it's a segment that goes from the center of the regular polygon to the midpoint of any side. So all you do is take 21 times that number, and you are good to go. That'll be your area, 127.306. And again, we're in units squared, whatever unit you're in. Okay, moving on. Find the area of this regular triangle. That is the task here, and we, for this one, thankfully, are actually given our apothem. right? The apothem goes from the center of the polygon to the midpoint of any side. So this is 1/2 times 14 times whatever the perimeter is. So it's 7 times the perimeter. Pretty simple. Let's find the perimeter of this thing. So here we go. Again, what I want to do is think about, let's see, think about this triangle as having, 120 degrees right there. Right? If you wanted to kind of separate that, you can see a little bit easier. The central angle of a regular triangle is 120. It's 360 over 3. Alright, so since we're dealing with 120 all the way across here, each one of them is 60 and 60. So what I'm going to do is extract my picture, make it a little bit easier to see here. So I've got a right angle, I've got this angle is 60 degrees, and I've got this as 14 units. Well, if that's 60, this guy over here is 30. Alright, so we can just pretty easily find what we're looking for here. Let's call it x. X in the big picture is half of one side. Alright, so let's, I don't know, I guess I'm not going to use both angles. I only need to use one of them, so I'll just use 60, I guess. So we're going to go, let's see, opposite and adjacent. Again, that's tangent of 60 is x over 14. So 14 tangent of 60. 14 tan 60. 24.2487. 24.2487. And again, that is half of the side length. So we need to add another one of those here. And then this whole distance is 2 of those x's, and then 2 more. So really, if you think about it, we just found x, and there are 6 of them all together. 1, 2, 3, 4, 5, and 6. So just take that number in the perimeter of the triangle. Triangle has 3 sides, but this is half of one side, so that's going to be, if that's 24.2487, multiply that by 6 to get the perimeter of the whole thing. So times 6, and then times 7. The 7's up here originally. It's 1/2 of the apothem. And we get 1018.446. Units squared. Alright, moving along. Okay, we have a regular decagon that has 10 sides. It's probably important to know that. 10-sided polygon. Has an apothem of 9.2. Find the area. Alright, well, I drew a decagon here using my computer program. And the apothem of this thing is 9.2. So let's draw that in there as well. The apothem goes from the center to, I'll use the bottom side, to the middle of a side. That right there is 9.2. And since you know that, then the other task, of course, is to figure out the perimeter, because the formula remains the same. So let's put this in, 1/2 times 9.2 times perimeter, and what is that, 4.6 times perimeter. Alright, so down here we have a little right angle, and if we find this little section, let's call it x, then we kind of have to multiply that by 20, because there are 20 half sides, because this x is only a half of a side. Alright, so here we go. Let's see. We need to think about what this angle is in here. And again, it might be helpful for you to think about it in this way. Right? If we have one whole sort of piece of pizza in here, Right, that guy has a central angle of theta. In a decagon, that central angle is 36 degrees because it's 360 over 10. Over 10. So there are 10 central angles that are all the same. So if it's 36 from corner to corner, then this must be not 36, but this must be 18. So your job really is pretty simple here. We've got an angle, 18 degrees, opposite, and adjacent. And it looks like we're using tangent again. So we go 9.2 times tangent of 18. 2.9892. 2.9892. And remember, that's only half of one side. So we have to multiply that by 2 to get a whole side. But there are 10 whole sides, so multiply that number, 2 times x times 10. Or if you're kind of slick, you can just multiply this guy by 20, which is what I'll do. That's the perimeter. What I'm calculating now is the perimeter of a decagon. Alright, so the formula said 4.6 times the perimeter will give you your answer. 275.012. And again, that's units squared, and you are finished. One more. Alright, so again, this is not the apothem. This is something different. If there's a name for it, it escapes me at the moment, but it goes from the center to a vertex. So if we were to kind of create another one of those diagonals, then we can pretty easily find this central angle, right? This is a hexagon. Hexagon has 6 sides and 6 central angles, so each of these is, let me redo that. Each of these is going to be, let's see, 360 over 6 or 60 degrees. All right, but we don't want that. We want half of that because we want to be able to use right triangle trig here. So half of 60 degrees is 30 degrees. And our apothem is right here. This guy we'll call x. So here we go. We've got, I'll draw a little bit bigger here. We've got a 30, 60, 90 special right triangle where the hypotenuse is 10 radical 3. And let's find a first. Alright, this is not really in the best position to use our special right triangle rules, so I'm just going to use cosine. Cosine of 30 is adjacent over hypotenuse. So I'm going to go 10 times, let's see, 10 times radical 3. Get out of that, get out from underneath that square root, times cosine of 30. And we get 15. Nice, neat number. That's cool. 15. And next we want to find this guy down here. So I'll use, let's see, I'll just use sine. Yeah, sine will work. So the sine of 30 degrees is equal to opposite over hypotenuse. You could have used tangent there, might have been easier. Tangent of 30 is x over 15. That definitely is easier, but I'll stick with what I started with. Sine 30 is x over 10 radical 3, so I'm going to go 10 radical 3. Get out from underneath the radical times sine of 30. I get 8.66025. 8.66025. And remember, that's only half of one side. The whole side would be 2 times that, which is, let's see, 8.66, 17.3205. That's the whole side length. There are 6 of those, so I'll multiply that by 6 to get my perimeter. And then up here, So it's 1/2. My apothem is 15. And my perimeter is 103.923. So I'll multiply that times half of 15, which is 7.5. 779.423. And that is units squared again. So there's our area.